when the British had left India, then the government did not have that much level of money to spend so that it can arrange 2 times of bread for their poor people. And at that time, the literacy rate of India is 12%, and the people who are living in poverty, it's about 70% of the total population. So from that we can understand what are the stage of the country at that time. And at that time, the India has thought about you know uh, touching the stars. And India has not only aimed about it, the India has dreamed about it. And after that in 1962, the India has launched the India has made its launched its ISRO, which is in Organization for Space Research, Indian Space Research Organization. And after that, as we can see, its first outbreak happens by the Aryabhat mission. And after that, most of the many successful missions has been held by the ISRO, like Chandrayaan 1, Chandrayaan 2, and Mission Shakti, MOM, that is Mars Orbital Mission, and many of the events we have done, like PSLV. So after that, MOM, as I talk about the MOM, Mars Orbital Mission, it is the fourth successful mission, and I mean India became the fourth country who has done the successful mission to go into the orbit of the Mars. And India became the first country who had completed this mission in first attempt. So due to its low budget, but due to our ISRO scientists' hard work and dedication, we are able to complete that. Our India is able to complete that. So now the ISRO has launched Aditya L1 mission. So Aditya means, it is a Sanskrit word. It is a Sanskrit word. It means the sun, and L1 is a point where this mission is going to be placed. L1 Lagrangian point. It means Lagrangian point is a point which is a stable point between the star and the planet. And they are about L1, L2, L3, L5, 5 Lagrangian point in our solar system. And Aditya L1 mission is the first mission of India which is going to study the sun. And let's just talk about it more. And actually there are many questions, as we know that we don't know about our own sun a lot, because reaching near to the sun is a very difficult task due to its high temperature. So that's why due to its high temperature, most of the parts get melted. So due to this, the solar eruption, the solar flares, and the solar winds, due to which it is very difficult to get near to the sun. So that's why this mission is a very complex mission. And there are many questions all around the world in the minds of the scientists about the solar flares. And it is going to answer the question, if it is possible, it is going to answer the question that actually at the surface of the at the outer atmosphere of the sun, the temperature is 6000, but when we go in depth about 1000 kilometer in the depth of the sun, then the temperature becomes 10 lakh degrees Celsius. So this becomes a very big question and big mystery. And solar flares are the mystery, and solar eruptive events are the mystery. And by this, the scientist is going to understand that how the energy transaction take place between the different layers of the sun. And let's see. According to this Aditya L1 mission, there are going to be 7 payloads, and these are not only designed by the ISRO. Many different organization of India has came, and they are making these 7 payloads. And so this is a joint mission, so this is not only the ISRO mission. A lot of organizations are working for it, like the Udaipur Research Organization, and many organizations like Aryabhatta organization are working. And many organizations are working. And now I'm going to talk about the 7 payloads. The first payload is visible emission line coronagraphy. So this actually focus on, when we are in a very high amount of bright sunlight, then we can't see most of the things due to the high sunlight. So that's why it is going to reduce by the oscillatory method. This is going to reduce the sunlight effect, and That's why we are able to that's why the scientist is able to see the hidden objects clearly. And this is a mission, and this is a working of the Helios, and it is also going to focus on the corona, the heating effect, and the second payload is suit. So this is going to the suit is going to imaging the sun in the wavelength of 200 to 400 nanometer, and it is also going to work in the um, you know understanding actually it is going to image the photosphere and chromosphere separately, so that the footprints of the eruptive events can be understood very clearly, that how they are formed and how they are created. And after that, the third payload is SOLAX. SOLAX is it is going to monitor the X-ray flares, and it is going to study heating mechanism of the solar corona. As I told, the outer temperature of the sun is about 1 lakh degrees Celsius, and the inner atmosphere temperature is about 6,000 degrees Celsius. So due to this difference of the temperature, the scientists, there is a very big mystery that how this at a small distance, how this um, vast temperature uh, conversion take place, and actually the things which are near to the sun should be more should have more temperature than the things which are outside or the away from the sun center. But this is what happening, this is opposite. So it helps the scientists to know this mystery, and to solve this mystery. And after that, Helios, it is going to understand the solar eruptive events and dynamic events which are taking place in the sun, and it is going to understand how this energy is helping to accelerate the solar energized particle, so that it gives rise to the solar eruptive events. And after that, PAPA, it means plasma analyzer package of Aditya. And solar winds, so this is going to understand about the solar winds and wind distribution. And aspects is also a sixth payload. And magnetometer is going to understand the magnetic field, interplanetary magnetic field, and to identify or measure the magnetic field around the sun. So this is what this is what Aditya L1 mission is, ISRO mission is. And thank you.